Now we'll do some examples using these identities. Example 1. If cosine of theta equals square root of 2 over 2, find the secant of theta. We'll use the identity secant theta equals 1 over cosine of theta. So that is 1 over the given value, square root of 2 over 2. Now we just have to simplify. We get 2 over the square root of 2, and I'll rationalize the denominator by multiplying by square root of 2 over square root of 2. That gives me 2 times the square root of 2 over 2. And the 2's cancel, leaving me square root of 2. By the way, before I go on, notice that I labeled what I was doing. So all this calculation was intended to come up with this secant of theta. So I started the calculation with that label. And that's really important so that your reader knows from the beginning exactly what it is you're calculating. Example 2. If cotangent of theta equals minus 1 over a, find the tangent of theta. So we use the reciprocal identity that tangent of theta equals 1 over the cotangent of theta. That's 1 over minus 1 over a, which simplifies to negative a. And again, I began the calculation with the label to indicate to my reader what precisely it is that I'm computing. Example 3. If the sine of theta equals 2 times the square root of 13 over 13, and cosine of theta equals 3 times the square root of 13 over 13, find the tangent of theta. So I use the identity tangent of theta equals sine of theta over the cosine of theta. And putting in the values we're given, we have equals 2 times the square root of 13 over 13 over 3 times the square root of 13 over 13. Inverting and multiplying, we have 2 times the square root of 13 over 13 times 13 over 3 times the square root of 13. Then we can cancel the square roots of 13. We can cancel the 13s, and that leaves us 2/3. And again, I've begun the calculation with a label telling my reader what it is I'm calculating. Example 4. If sine of theta equals 3/5 and cosine of theta equals negative 4/5, find the cotangent of theta. We use the identity cotangent of theta equals cosine of theta over the sine of theta. That equals negative 4/5 over 3/5. Inverting and multiplying, then we have equals negative 4/5 times 5/3. The 5's cancel, leaving us negative 4/3. And again, I've begun my calculation with a label stating right from the outset what it is I'm calculating. Example 5. If cosine of theta equals minus square root of 2 over 3, find cosine squared of theta. We don't need any identities here. We're just being asked to square the cosine value. So this is basically a little practice with that notation. Cosine squared of theta means cosine of theta and then squared. So I'm squaring negative 2/3, which gives me 2/9. Beginning with the statement of what it is I'm computing. Example 6. Find the sine of theta if the cosine of theta equals 12/13 and theta terminates in quadrant 1. So I'm given the cosine and I want to find the sine, which means I'm going to use one of the versions of sine squared of theta plus cosine squared of theta equals 1. Now you can start with that if you want and solve for sine, but I decided to start with the version of that where sine has been solved for, which is that the sine of theta is plus or minus the square root of 1 minus cosine squared of theta. Now though, we're given a little bit more information than just the value of cosine. We're told that theta terminates in quadrant 1. So theta is in quadrant 1 somewhere, and in quadrant 1, the sine of theta is greater than 0. So I know that I can choose the positive square root. By the way, this double arrow, the arrow with the two horizontal things, is math shorthand for the word implies. So the way you would read the second line is, but theta in quadrant 1 implies that the sine of theta is positive. Okay, so we have sine of theta is positive square root of 1 minus cosine squared of theta. I'm going to put in that theta is 12/13. So I have the square root of 1 minus 12 squared over 13 squared. I need a common denominator to do the subtraction inside the square root. That common denominator would be 13 squared. So at this point I have 13 squared minus 12 squared over 13 squared inside the square root. That denominator simplifies immediately because the square root of 13 squared is 13. Up top is a little more work. I get 169 minus 144 inside the square root. So square root of 25 over 13, which is 5/13.